And then when the container, because containers are supposed to be short-lived, when it, you know, goes down and then it starts back up, it's using that new patched image, and it kind of just rolls through the environment like that.
That's generally right. I'll dig in a little bit more. I'll go like a layer below that. That's like directionally very right on. Again, I mentioned that at the heart of our solution is this ability to patch images. And we do that on an image, and it's your image. So at its edges, our system's kind of schematically, it works at a high level like this. You attach it's a SaaS service, so it's a patching service. You attach us to your registry where you keep your images. And typically we start by operating on an organization's base images. Think of like Node on Debian or or Node on Alpine or PHP on Debian or Elasticsearch on Debian. Like you have these kind of app foundation images where you have like a Node or Python environment, or you have like, I'll call them infrastructure applications like Redis, Postgres. These are the kinds of images I'm talking about that you start with. And that cleans up, by the way, when you get these to be clean, that takes a ton of vulnerabilities out of the environments because these images get propagated over and over again, right? You build as a company, you build your images on these foundational images, and then and you derive a lot of your microservices from the same base images if you're doing your DevOps homework, right? So we focus on those, I'll call them foundational image sets. They're the 10 or 15 or 20 core images you use to build your SaaS from and you derive from. As you know, with images, you can, in Docker files and other means, you can derive from, so you can do like a multi-stage build. The first thing is you build your base, and then you add more layers to it as it goes. And that's kind of a pragmatic way to organize around these base images. So we plug into your registry. So you just put a registry integration into our system. You can tie us into your CI/CD pipeline, so you can trigger us to run whenever you want us to create a new base image for you, or I'll call it AVR your base image, patch your base image. These base images often come from places like Docker Hub, or it's something somebody generated that first Docker file for, but a lot of times they come from community sources or public sources, and then they get modified. But we start with those images. And then if you want us to act on it, you just tell us to go and act on the image by triggering us with your CI/CD pipeline or through our UI. I'm happy to do a demo later on in this session to show you exactly what it looks like. But once we run, we literally pull the image into our system, into our SaaS. We open it up. We analyze its components. I'll say largely we use a simplistic model, but containers are layered. They have something called a layered file system, right? And the base image lives in whatever layer was specified, and so on. You build up. And some containers I've seen that have as many as like 100 layers, but on average they
Nice.
have like 4 or 5, 6, 8, something like that. Small number of single digits number of layers. So in a simplistic model, most containers that go to production have like a 4 macro sets of stack. It's like the operating system or the very base layer. It would be like Debian Bookworm, right? And then you have another layer, I'll call it macro layer. It could be multiple container layers, but the next thing is like application foundations or applications. So that's where Redis would fit into the container stack, or Python, the app foundation, the library Python, right? Like Python you might install on your computer with its basic packages. Layer 3 of that stack would be like the Python libraries I need for my requirements.txt to actually build the application that I'm trying to build. And the fourth is called first party code. It's code you write that uses all that stuff, just like you do it on a computer, but in a container. We worry about third party code, those first 3 layers of that stack, making that secure and patching that. And that's, as you mentioned, we apply patches. So we apply 2 different kinds of patches. Our system can automatically apply patches to those first 3 layers by simply doing upgrades. And we have a patch planner that knows how to do that in a way that's very low likelihood of breaking your application. We look at the composition of the container, and we choose upgrades that are safe. That's kind of a cool tech that we've created that kind of does some estimation on that. And then even if you do a perfect job at that, there's going to be lots of vulnerabilities left over because many vulnerabilities don't have patches in the ecosystem. Debian is notorious for this. About 70% of all the containers in the world are based on Debian that run in cloud native environments. There's a large number of vulnerabilities that are critical and high that Debian does not have patches for because they've decided to defer patching those to future versions of their operating system. and they kind of leave it up to the community to figure out, but no one does. So the other part that we do is we go make patches where they don't exist in the world. And we have a very big library of patches we've developed you can't find anywhere else.
Really? Wow.
We've built an agentic AI system that augments our research team, and it does this extremely efficiently and extremely accurately. We've invested a lot in automation and a lot in agent technology over the last year and a half to make use of the cutting edge of AI tech to do this. It's a really complicated thing, meaning like making these patches requires, well, we patch times hundreds of libraries, and it would be like nearly impossible for engineers to understand all of those. Like we literally have to understand all the source code in those libraries. Like it's hundreds of open source libraries to patch. Expert knowledge required. We have a great research team of expert patchers, guys who know how to do this work really well, and they like doing it. The first thing is nobody likes to do this work. I got guys who like to do this work. Um, and and we've made agents that love to do this work. And it turns out that agentic AI is really good at this problem. For instance, Claude, Anthropic's agent, they've spent a lot of investment in making Claude a really good coder. And it turns out this is one of those coding problems that we figured out how to make these AI tools be really, really good at. Now, obviously, we know how to do it and we're really good at it. And we have lots of examples and we have lots of training data and we have lots of things. But at the core of our system is this ability to create patches where none exist, and then patch in a way that doesn't break things, be really surgical with all the upgrades and patches. And then third, our system automatically applies them to the container image by creating a new container layer where all the patches go. We then once we figure all that out, we get all those patches there, we then build a new image and then push it back to your registry, and we just tag it with _root.io. And the combination on an average, like say, I can show you later a Python image that we do this for. The amount of hours, it's dozens and dozens. If you could even figure it out, like we can patch an image in 3 minutes that would take any team, like literally any team, with any other competitive solution or approach, days, maybe weeks. And our system can do it in like, well, I'll show you while we're on this call. Now, that's a culmination of a lot of really cool research and work and engineering and building this massive software factory in the back end of our system. We've got a SaaS platform that makes it really easy to interact with and connect into your world. Everything's got APIs, but that's pretty much the high level thing. Container in, analyze, plan, apply patches to wherever we need them, reconstruct the container, emit the container, and you're done. It happens in about 3 minutes. For the average container size, your mileage may vary depending upon the size of the container. Now, the other thing I should mention is that as soon as we see your image, and that's your image, by the way, I didn't make you change over to my image. That's your image. Whatever image you chose to direct us to try this on. Competitive solutions, most of them are image libraries. They sell you a bunch of images. They're super expensive. The way they deliver them is super expensive for them to do. That's why they pass those costs on to you. And it requires you to rebase your images. So to start with those solutions, you got to go back to your engineering team and go, hey, listen, I got a great solution. Everything's going to be great. All you need to do is re-engineer all the images we have to use this new operating system. It's going to break everything in the beginning, but that's okay, because as soon as we get over that massive toothache, things are going to be good. But they actually don't turn out good because many applications can't port. Like if you're on Debian or Ubuntu, you try to go to Alpine, stuff just breaks. And you've got this massive lift.